How I built a secure SSH lane for AI agents using Cloudflare starts with a simple problem. I wanted remote agents to test on a powerful Mac, run Xcode checks, boot an iOS simulator, and write QA reports. But I did not want public SSH, router port forwarding, shared passwords, or agents landing inside my personal Mac account. So the goal became clear. Build a controlled lane that agents could use, then prove every layer before trusting it. This was not about whether SSH can be turned on. That part is easy. The real question was whether an agent could reach the Mac without exposing the machine in a careless way. No public port, no password login, no personal credentials, no broad access to my home folder, private keys, Codex state, Claude state, GitHub auth, or project secrets. I needed access, but I also needed boundaries. The instruction was outcome-focused. Help me build a secure remote testing lane into my Mac for AI agents, using Cloudflare, SSH keys, dedicated macOS users, and hardening checks. Codex turned that into a layered design. First, prove the Mac can accept local SSH. Then put Cloudflare Access in front of it. Then give each agent its own service token, SSH key, and local account. Then verify Xcode and simulator control. Then harden the file boundaries. The final shape is not one magic security switch. It is 5 layers working together. The Mac connects out through a Cloudflare tunnel. Cloudflare Access decides which identity is allowed to reach the SSH hostname. SSH keys decide which local account the agent can enter. macOS user boundaries limit what that account can see. Then a hardening pass closes accidental visibility between users and tool metadata. The tunnel is only one layer. The first proof was Cloudflare Tunnel. The target Mac ran Cloudflared as an outbound connector, so I did not have to open port 22 on my router. The protected hostname routed back to localhost port 22 on the Mac, and Cloudflare Access sat in front of that hostname. A human login proved the route first. Cloudflare Gate, Tunnel Connector, SSH service, and local Mac login all had to work before an agent entered the lane. For headless agents, browser login was the wrong long-term path. The durable version used one Cloudflare Access service token per agent, one service auth policy per agent, one SSH key per agent, and one standard macOS user per agent. That matters because revocation becomes clean. If one agent should no longer connect, revoke that token, remove that SSH key, or remove that macOS user from remote login. Do not share one identity everywhere. The proof was not a diagram. The proof was a real SSH session through Cloudflare Access, landing as the dedicated agent user with password login disabled. From there, the agent could run WAMI, hostname, Xcode build version, and SimCTL. Then it booted an iPhone simulator and captured a screenshot. That was the moment this stopped being an experiment and became a working remote test lane. After the lane worked, the security pass mattered. A standard macOS user is not a full sandbox. It can still run processes, consume resources, right inside its own home folder, and use tools you make available. So I checked what the agent users could read, tightened home folder permissions, protected shell and Git config files, restricted Codex and Claude metadata folders, and kept a deliberate shared handoff folder for outputs. The takeaway is simple. Do not confuse remote access with controlled access. Cloudflare Tunnel solved the inbound connection problem, but the operating lane became safer because every layer had a job: access policy, service token, SSH key, dedicated macOS user, local hardening, and kill switches. That is the pattern I want for AI agent infrastructure now. Make the lane useful, make it narrow, and make it easy to shut off.